amounts of substances. This topic looks scary because it mixes chemistry with maths, which is already a red flag for most people. But once you understand the logic, it becomes predictable. And predictable is exactly what you want in an exam. Relative formula mass. Start with the idea that every element has a relative atomic mass. This is just a number that tells you how heavy one atom is compared to others. A compound is made of more than one type of atom. So its relative formula mass is simply the total mass of all the atoms added together. There is nothing complicated here. You just add numbers. Take magnesium chloride as an example. It has one magnesium atom and two chlorine atoms. Magnesium has a mass of 24 and chlorine has a mass of 35.5. So you do the obvious thing. Add 24 and 2 times 35.5. That gives 95. Same idea for iron oxide. 2 iron atoms and 3 oxygen atoms. Multiply and add. No magic, just arithmetic. If you mess this up, it is not chemistry failing you. It is basic counting failing you. A useful habit is to always write out how many of each atom you have before calculating. It prevents stupid mistakes. Percentage mass. Now we take it one step further. Instead of asking how heavy the whole compound is, we ask how much of that mass belongs to one element. This tells you how important each element is inside the compound. The rule is simple. Take the total mass of that element inside the compound, divide by the total formula mass, then multiply by 100. Example with magnesium oxide. Magnesium has mass 24 and oxygen 16. Total is 40. Magnesium's share is 24 out of 40. That gives 60%. So magnesium makes up 60% of the compound. This becomes useful in exam questions where they hide the answer behind percentages and expect you to work backwards. If you stay calm and follow the steps, you win. If you panic, you lose points for no reason. Using percentage in mixtures. Now things get slightly more interesting. Sometimes you are told a mixture contains a certain percentage of an element, and you must figure out how much of a compound is present. This is where students usually fall apart. Here is the logic, step by step. First, find how much of the element is actually in the mixture. For example, if a mixture is 50 grams and contains 20% iron, then it has 10 grams of iron. Second, figure out how much iron exists in the compound itself as a percentage. Third, use that percentage to scale up and find the total mass of the compound. You are basically solving a proportion problem. Nothing more dramatic than that. The mole. This is the part everyone pretends to understand. A mole is just a counting unit. Like saying a dozen means 12. A mole means a very large number. Specifically, 6.02 times 10 to the power of 23. You will never count that many things, so stop imagining it. Just accept it as a unit. 1 mole of anything contains the same number of particles. That is the key idea. That means 1 mole of carbon atoms and 1 mole of water molecules both contain exactly the same number of particles. The only difference is their mass. And here is the trick that makes everything easier. The mass of 1 mole of a substance in grams is equal to its relative formula mass. So if carbon has a mass of 12, 1 mole of carbon weighs 12 grams. If carbon dioxide has a mass of 44, 1 mole of it weighs 44 grams. This is the bridge between mass and particles. Calculating moles. You use one simple formula. Number of moles equals mass divided by relative formula mass. If you have 42 grams of carbon and carbon has a mass of 12, then divide 42 by 12. You get 3.5 moles. Same idea for compounds. If you have 66 grams of carbon dioxide, divide by 44. You get 1.5 moles. That is it. No tricks, just divide. Finding mass from moles. Sometimes they flip the question to make you uncomfortable. Now you are given moles and asked for mass. So you rearrange the formula. Mass equals moles multiplied by relative formula mass. If you have 0.80 moles of sulfuric acid and its formula mass is 98, multiply 0.80 by 98. You get 78.4 grams. Same logic, different direction. If you cannot rearrange this, the problem is not chemistry. It is basic algebra. Key understanding that saves you marks. 1 mole always means the same number of particles. Always. Different substances just have different masses for that same number. If you really understand that, half the topic becomes obvious. Questions and answers. Question: how do you calculate relative formula mass? Answer: add the relative atomic masses of all atoms in the compound. Question: what is the formula for percentage mass? Answer: mass of the element in the compound divided by total formula mass multiplied by 100. Question: what is a mole? Answer A. A unit that represents 6.02 times 10 to the power of 23 particles. Question: what is the mass of 1 mole of a substance? Answer: it is equal to its relative formula mass in grams. What equation links moles and mass? Answer: number of moles equals mass divided by relative formula mass. Question: how do you find mass from moles? Answer: multiply moles by relative formula mass. Question: how many moles are in 42 grams of carbon? Answer: 3.5 moles. Question: how many moles are in 66 grams of carbon dioxide? Answer: 1.5 moles. Question: what is the mass of 0.80 moles of sulfuric acid? Answer: 78.4 grams.